The following sheet has to do with the plan and profile of the main street called Street A coming through the project site. We'll have a plan and profile sheet also. So first I want to talk about the plan view. This is the top view at the top. And the profile is basically a section view of the center line of the road as it's shown here. So in the plan view, what you have is similar to the paving, grading, and drainage sheet. You have the lot grade or the lot drainage type A, B, or C, the lot number, and the finished floor elevation. Now notice on this one, they've got little bubbles around these finished floor elevations. The reason that is because these were submitted and then revised. The bubbles mean that somebody revised the elevation of the plans. So you won't have little bubbles around your drawings. It's only because somebody made comments to the set of plans and the engineer revised the original set of plans. Now, in the plan and profile, you'll have the stationing where it says 12 plus 00, 13 plus 00, 14, etc., etc. You're going to be doing a design where you can actually read from the lower station equation, which is a 10 plus 00, all the way to the 27 plus 00, from left to right, because that's normally how we review plans. Now, on this, in the plan sheet, you also show the utilities, the storm, the sewer, and the water. So it gets a little bit clustered, and you also have the existing topographic survey in here. Now, usually you would make the existing topographic survey much, much lighter than what is showing up on these sets of plans. So maybe this is just a bad print. Also, what you have is the utilities for sewer, water, and storm. The reason that is because down here in the profile view, you have the lighter line, the thinner line, which typically is usually dashed as the existing ground. And then you have, the darker line is the existing ground. And then you have this line right here, the thinner, lighter line, which to me is actually reversed. This top line is existing and should have been dashed, and this bottom line is proposed, and it should be darker and thicker. The bottom line here is what the ground or what the center line of the road is going to look like. So it's coming out 0.5%, going down a -6%, then a -3.78%, and then back up. So the absolute low point, if I drew on this, the absolute low point would be right here. That corresponds station equation at 1350. If I look up here, the station equation at 1350 is where those inlets are. So that's how I knew that water is going to travel down the street on both sides and into the inlets. Now notice what you have up here. You have a vertical curve in 3 different points. So the vertical curve is needed because of the transition in grades. You need to have a vertical curve when you have the algebraic difference of the curves coming in and out is greater than 1. The reason that is you don't want to have too much of a slope change because it causes an uncomfortable ride. So if you have a vertical curve algebraic change difference greater than 1, then you need to put in a vertical curve. So that's what these are. And the minimum vertical curve has to do with this K factor, and you can look it up in the FDOT Green Book. We'll go over more of this information in the Highway Drafting and Route Design class. The other thing that's in the set of plans is you'll notice here on the bottom it says SAN-MH1. If I look at the top at station 10 plus 96, you'll see this manhole. So this manhole corresponds to this one here. So it's telling you what the top of the grate is, or the rim elevation, and the invert being this information down here. It goes to sanitary manhole 3. You'll see the tie-in as the invert, a north-south, a west-south, and north invert, and the rim elevation. The other thing that you'll see is on this one, you can see that there's a manhole here and a manhole here. This is telling you the tie-in elevation of each of those. The elevation see how far it is? You can see station such and such, street A, station such and such, court A, and it's got the elevation associated with it. Now, you have BVC and EVCs, I'm sorry, going back to these vertical curves, beginning of vertical curve, beginning of vertical curve elevations, what that means. And this automatically, this information that I just deleted, automatically gets generated when you create the vertical curves. Now, in the videos, in the later videos that I have for this class, I'll show you how to generate the pipes and the pipe networks. Now, you also have in here, this information is for the storm and this information is for the sewer. Now, these lines right here, that are paralleling the center line of the road, proposed road, is going to be your water main. And it says maintain 3 feet of cover. So out here at the edge of the road, you actually have the proposed water main, this 8-inch water main. And that's what these dark lines are representing. So we'll have sewer, water, and storm exactly like this in our plan and profile. Now, notice the other thing that's in this sheet of paper is that down here you have the station and you have elevation 93.2 and an elevation 93.95. Well, one is existing ground and the other is proposed ground. So the ones with double digits is proposed. On this side, these are the elevations. Notice that between these two stations there's 100 feet, and between these two elevations is 10 feet. So there's a graphical exaggeration on those scale. And notice, remember when I said at the beginning of the video that you have these bubbles around it? Here's the reason why you have the bubble. It says this sheet was revised, and anything with the bubble is the revision on this sheet. The other thing that you have here says match line station 24 plus 00. That means they couldn't fit this entire roadway length on one sheet. So at station 24, about here, they had to shift and put it on a second sheet. So you can see the second sheets down here, the continuation. You have a plan and profile for each of the cul-de-sacs also. So you'll have court A and court B. And in each of those, again, it shows you the sewer, the storm, and the water that is located on these roadways. Okay? Now, we will be doing a plan and profile sheet for our project also. Notice the other thing in here is the basin information for the pond, the discharge information. Okay? That's it for this video, and this is about plan and profile sheets.